This presentation concerns parallel circuits. Here you have one that seems to be operating, and it's providing currents through 3 light bulbs in parallel. So let's go back to Kirchhoff's current law. You can find this first discussed in the presentation entitled Kirchhoff's Laws. The current law states that the algebraic sum of the currents into and out of a circuit node is always 0 amperes. This is true for any type of component. A parallel circuit forms a ladder network of components. The source of voltage is the same as each of the voltage drops along the ladder. There's only one voltage value in the entire circuit, just as there's only one current value in an entire series circuit of one loop. If the components are resistors, Ohm's law applies to each resistor. The sum of the currents in the parallel components is equal to the current provided by the source. Resistors in parallel add reciprocally. 2 100 ohm resistors in parallel are equivalently equal to a single 50 ohm resistor. Because they provide 2 paths, the resistance seen by the source is lowered, not increased. The formula for finding the equivalent resistance of resistors in parallel is 1 divided by the equivalent resistor is equal to the sum of the reciprocals of the resistances of the resistors in parallel. And here we have an equation that always works, and that's 1 over R equivalent equals 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over Rn, R sub n, where you have n resistors in parallel. When paralleling 2 resistors only, you can use the abbreviated equation. R equivalent is R1, R2 divided by R1 plus R2. You can only use that for 2 resistors in parallel. Here's an example of a parallel circuit with 4 resistors in parallel. In this circuit shown, the voltage across each resistor is 9 volts. The current in each resistor can be found by dividing 9 volts by the value of the resistor, Ohm's law. The total source current can then be found by summing the resistor currents. The total current can be verified by finding the equivalent resistance by reciprocally adding the resistors as explained in the preceding sign. You can do this as an exercise, but remember that you can do it either way and use the other way as a check.